it can be divided by 3. So I can say 3 is a factor as well. And if I write all the factors, I think 6 will be there, 8, no, not 8, 9, 12, 18, 36. Is there any more? Okay, I think these are the factors of 36. Anyway, so we'll actually try from the factors, considering the plus minus values as well. And we can also try fractions of these as well. So if I try a -1, let's see what happens. The reason I'm trying -1 is because my intuition says, because of this 51, okay, if I take something negative, this might help me, because I've already -36 here, which doesn't really matter what the value of x is, because that's a constant term. And this 36 plus this -13 is 49, and plus this 3, if I take negative, this will be -3. So 49 plus 3 will be 52, and I'll have 51 here and 1 here. So overall, looks to me that I'll have a 52 minus 52, which will give me a 0. Which it actually looks to me, that I'm not really sure. These are really assumptions. When you practice a lot of problems, you can eyeball that, and probably you get an idea which value could lead us to our real 0. So as I said, it looks to me that -1 might give us the result. So let's see. Okay, -1 to the 4, 3 to the -1 cubed, minus 13, oops, sorry, -1 squared, 51, -1, minus 36. It will be +1, it will be -3, as I said, it will be a -13, it will be +51, it will be -36. And as you can see, this +51 plus 1 will give us a +52, and the rest will give me a -52. So as I said, I'll get a 0, right? So that means this is actually one of my real zeros, okay? And if you remember, whatever my real 0 is, we said x minus that is a factor for us, factor of f rather, not for us anyway. So that's the factor for f. And on this occasion, my real 0 is -1, okay? So that means x plus 1 is definitely a factor of f. F means this function, right? Okay, so that means, let me write the function first. X to the 4th plus 3x cubed minus 13x squared minus 51x minus 36. Did I write it wrong? No. Okay, so that means we'll actually factor out x minus from this in a way so that it can give us x minus 1 for all the pairs. We'll actually set up pairs for this, for each of which pairs will actually get x plus 1. So the idea is we write x plus 1 here, and we try to factor out from the first term on our hand. So from x to the 4, if I factor out 1x, what will be left? I'm factoring out 1x from this Okay, I have one answer, x cubed. Yeah, that's right. So I'm actually factoring out one single x from this x to the 4. So I'll have x cubed, right? So next, what I'll do, I'll actually go backwards. This is one of the naive approaches, but it actually works really well. You know, it's quite effective. So we know that this will give us x to the 4, which we already have here. So that's all right. And if we multiply this two, I'll get plus x cubed. Oh, sorry, plus x cubed, right? So that's the first pair done. That's the first pair. That's the first pair, okay? I'm trying to rewrite the entire function in a way, as I said, for which I'll get x plus 1 as a factor. Okay, now we know that our main function had 3x cubed. How many x cubed we have in our second line? 1, right? So we still need to have 2 more x cubed because I'm writing this equal sign. That means all of these values are exactly the same. We are not really adding or subtracting anything from the entire value, right? We're keeping the value intact. So I'll add a plus 2x cubed. Now, these two combinedly gives me 3x cubed, right? So I'm not really doing any harm to the entire function. Anyway, so I'm going to remove this because otherwise this will create confusion. Okay. Now, plus, again, I'll factor out x plus 1 from the first term we have in our hands. Okay. And if I factor out x from this 2x cubed, what will be left? Can you see that? If I take 1x from it, no, not x squared. Anyone else? Just factor out 1x from that.
X cubed.
No, I'm already taking or rather factoring out 1x from it. Obviously, the first term in our hands, 2x cubed, as I said. Whatever we have after we set up pair, this is already done. This is the pair for this. So now we have in our hands is 2x cubed. If I factor out 1x from it, what else will be there? Just factor out 1x from it. Two x squared, exactly. Now, yeah, now you got it right. So this will be 2x squared, right? If you are still wondering why, or rather how I'm doing this, just simply make sure that if you multiply these two in return, you will get this. So if you multiply 2x squared with x, you will definitely get 2x cubed, right? Okay, so now we have already multiplied this. Next up, we'll multiply 2x squared by 1. If we multiply that, we'll get 2x squared, right? Anything you multiply by 1, it remains the same. So that's the pair. Let me erase some of this, otherwise it will get clumsy. Okay. Now, you can always see the videos I'll upload later on and check this again and again if you want. So now this is the pair for these two, right? As I said, for each pair, we want to get x plus 1. Now, I have 2x squared here, but how many x squared I had initially? Negative 13. So what else I need to write here to keep this value intact? I initially had negative 13x squared, but instead I have, to make the pair to form the pair, I have written 2x squared. Daria, you are almost right. Almost. Try again.
Negative 15x square.
Exactly, yeah. Daria missed that x squared. I know she knows that, maybe probably she forgot to write the exponent. Anyway, so I had negative 13x squared. I have written plus 2x squared. So that means I need to write a negative 15x squared, because if I remove this, you'll understand it better. But now, as you can see, negative 15 plus 2 gives us, I should use the opposite direction. Yeah, it gives us negative 13x squared, right? That means we are keeping our value intact. Okay, can you see what I'm doing here? And again, for this pair, I think I'll need more space. Okay, let's try this way. Let's carry on, and later on I'll use another space. Okay, so again, I'll factor out x plus 1 from it. Okay, and now, as I said, this is the pair for this. So next up, we want to factor out 1x from the first element in our hands, which is this one, right? If I factor out x from this, what else I'll have? Negative 15x. Very good. So let me write that. Negative 15x. Okay, I'm running short of space, so I think I'll need to switch to another place here. Can you understand it? I hope so, if you're following it closely. Anyway, I'll go for the next line later on. Let me first finish this pair. Okay, so 15x times x will give us 15x squared. So this one is done and dusted. For 15x times 1, what we'll have? Can you see that? Just multiply that by 1. Exactly, very good. We'll have a negative 15x here, right? Okay, so now I'll move to a new space. I'll actually rewrite all of this, but just to make sure that we are actually done up to this, right? This pair is for this, so we are done up to that. So now let me start from the second line. Okay, so this is the second line, by the way. I'm trying to do it for you. So the second line has been so far x to the 4 x cubed 2x cubed 2x squared minus 15x squared minus 15x. Okay, that's what we have so far in the second line. That's it. That's the second line. I'll need more space. That's why I'm trying to switch here. Okay. Let me write the first line as well. Otherwise, it will be difficult to scroll down every now and then. 15x, 51x rather, leave 36. Okay. Now, in our third line, we had x cubed, x plus 1, plus 2x squared, x plus 1, negative 15x, x plus 1. Okay, if you don't understand my handwriting, don't hesitate to ask to rewrite that, because I'm writing it in a smaller format rather, font. So it might seem unreadable to you guys. I hope not, but if you don't understand, you can say that. Okay, so we are done up to this, but initially, as you can see, we had 51x, a negative 51x precisely, but now we have negative 15x. Now what else we need to write? Negative 36x, very quick. So negative 36x, because now as you can see, this negative 15 and negative 36 is actually negative 51, right? So we are keeping our value intact. That's really important. I'm going to erase this. Okay, now next, once again, we'll factor out x plus 1. If I factor out x from this, what we'll have? What will we have? Negative 36. Negative 36. Now, we know that 36 times x will give us negative 36x. What will happen if we multiply negative 36 by 1? That will be negative 36, right? Negative 36. And finally, this is what we had initially. So we don't need to do anything else. This is definitely the pair for this. So that's it. We are done with setting up the pairs. That's the first thing we want to do. Any question up to this? Because if you don't understand what I'm doing here, the later stage will not really make any sense, because this is the most difficult part, if there is any. The next part is pretty simple. Okay, to set up the pair is probably the hardest thing. Okay, anyway, let's move on. Meanwhile, if you see anything that you want me to rediscuss, you can say that. Okay, now as I said, x plus 1 is the factor of f. That means we can now, oops, I think I can erase this. Now we can actually factorize x plus 1, right? So if I factor out x plus 1 from each of the terms, from all the terms, I'm trying to factor out x plus 1. So let's do one by one. If I factor out x plus 1 from the first term, what else I'll have in my hand? I've already taken out this x plus 1, okay? X cubed, very good. X cubed. I'm doing the same thing. I'm factoring out x plus 1 from this. What else will be left? 2x squared, good. And if you keep doing that, you'll have 15x in the next and negative 36 in the next, right? Now, it's definitely a factorized format, right? This is already factorized. Can you see that? Because factorized forms look like this, where you have two different items as a product. So it's definitely a factorized form. Not for all the problems, but for some problems, you'll be able to factorize this as well. So you can actually work furthermore. You can simplify it more. You can factorize it more. But this is definitely one of the factorized forms. So what we'll do, we'll just check whether it can be factorized anymore or not. For some problems, you will see this will be the last form. But for this particular problem, I know, because I have checked it before starting the lecture, that it can be factorized even further. So let's try that. So again, for this particular one, I'll actually look for the real zero. Okay. And for that one, what I can do is I can factorize it by plugging in x equals negative 3. So what I'll do, let me show it in a separate place. Now my let's say g of x. Okay, now my function is x cubed plus 2x squared minus 15x minus 36. Okay, and as far as I can see, negative 3 will give us a real zero. Let's try negative 3 cubed plus 2 times negative 3 squared minus 15 times negative 3 minus 36. Negative 3 cubed will give us negative 27. Negative 3 squared is 9 times 2 is 18. Negative 2, negative 15 will give us a negative 45, oh sorry, positive 45 rather, and minus 36. And excuse me. And as far as I can see, 18 plus 45 gives us a 63, and 36 plus 27 will also give us a 63. So that's one of the real zeros, right? So that means we'll actually repeat the same process for this. Now our new factor will be x plus 3 instead of x plus 1. Okay, let me quickly show that to you. I'll actually keep this. We'll start from the next line. Okay, so now I'll try to factor out x plus 3. If I factor out 1x from this, what else will be there? Well, if you get a real zero, so that means x minus that will be your factor for that particular part. So for g of x, for this part here, we have got a real zero. Well, as I said, you need to use your intuition, and the more you practice, the more you will get that. There is no hard and fast rule for it that, yeah, I can see a problem and simply plug in a value. That won't happen here. The more you practice, the more you will get an idea. Well, you might ask me, how did I get that? Everyone might have a different approach to it. But what I see when I see a problem, of course, I try to look at the factors of the constant term, which is 36 here. And as you have seen, we already know what are the factors of 36. There you go. Next up, what I see, which value, because it's a factor of 36, and you have to plug in factors of 36 to find the real zero, and negative 3 just happens to make it. Yeah, that's true. But the technique I use, is I try to eyeball which value is giving me the opposite of this constant term. Now, you might be wondering what I meant with the opposite. Well, as you can see, you have a negative 36 here, you have a negative 15x here. So that clearly means if I take anything positive, it might not give me the result unless it's really big or really small, either of that. But if I take any, that's my intuition, as I said, that my approach. Anyone might have a different approach, doesn't matter, because for solving this type of problems, there are several ways, several techniques. But as I said, the more you practice, the more you'll get an idea. Can there be any other alternate way to factor it? As I said, yeah, of course. Not for all problems, but for many problems, you'll have alternative options, alternate ways to factorize. Definitely, you can Google that. If you don't like this approach, although this is very straightforward, this is really easy. As I'm showing this slow step by step, that's why it's taking so much time. But it doesn't take this much time. You can actually do that probably in 1 minute. But if you are doing this for the first time, or for the first couple of times, you might take some time. But as you practice more, you'll grow in confidence that, yeah, you can do that. So if you want to do this, what I will suggest, take 1 or 2 problems after we finish, and then try this at least 2-3 times, and I think this will make your life easier. Okay, so will it always be a factor of both numbers? For example, negative 15 and negative 36 share a factor of 3. and originally 1 is a factor of -1. No, it doesn't really work this way. It depends on the factor of the constant term, not the other terms in general. Okay. Okay. So my approach is, as I'm looking at this problem, my intuition says something negative should give us my result. Although I won't really say that you won't get the result by plugging in something positive. That's not the case. But as I said, my intuition says when I'm eyeballing this, that if I plug in something negative, it should give me my result. And as I have -36 here, okay, so that clearly means I need at least something bigger than 1, because -1, +2, +15 won't give me -36, okay, or rather anything close to 36. That's how I get these values. It doesn't really mean that I always get it on the first place, in the first place. So I need to practice. I need to try 2 or 3 different values as well. So there is no hard and fast rule for it, at least for this approach. Okay. Anyway, so now, yeah.
Do you mean that you just look for any number that if you can replace it with okay, you'll replace x with it, you get a 0?
Sorry, I can't hear you. Can you repeat it?
Okay, I mean, do you mean that you just look for a number whereby you can plug in a place of x and sum up and you get a 0?
Yeah, of course. Yeah, that's it. I just try and look for the values. I plug it back there. May or may not, work in the first place. Then I plug a different value, and in general, when I try 2, 3 values, I get at least 1 real zeros for it. Okay, that means what I mean by real zero is the value which gives me this 0 in return. Okay. Okay, so I'm trying to factor out now x from this x cube. So I'll have, let me do it real quick, otherwise I won't have enough time for the asymptotes. Oops, sorry. This will be x cubed. So if I factor out x from this, I'll have x squared. So multiplying this will give us x squared. And now I'll multiply x squared by 3. So it will be 3x squared, right? But previously we had 2x squared. This is the pair for this. We are already done setting up that pair. So as we have more x squared here, at least 1, so we need to subtract it, right, to make the balance. Can you see that? Now again, I'll try to factor out x from this. So I'll have x here, because this x and x will give me x squared, which I was looking for. And this x and 3 will give me a -3x. Okay. But originally, this is the pair for this, by the way. But originally, I had a -15x. Instead, I have a -3. So I need to add 12 more, right, to make it 15. And you see what I'm doing here? And once again, I'll factor out x plus 3 from it, and factoring out x from this will in return give me 12, and this 12 and 3 will give me -36. That's what we had. Close the braces. Now we can once again repeat the same procedure. We'll, pardon my bad handwriting. Let me try once more. Okay. Now once again, I'll factor out x plus 3 from each of these 3 items, each of these 3 terms. I'm taking x plus 3 from this, I'll have x squared here. I'll have a negative x here. I'll have a negative 12 here. I think I can ignore that here. So that's your one step more factorized format. That was definitely one of the factorized format, no doubt about this. This was also factorized, right? But we can actually simplify it more and get more factorized. And ironically, you can actually factorize it more. You know, so for that, we don't need to go for this longer process. If you remember Math 95, Math 96, we can use our concept there. That means we are looking for a value whose product will be negative 12. We're looking for a pair of values rather, whose product will be negative 12 and whose sum will be negative 1. Okay, do you remember this process? Do you remember this? I hope you do. Whose sum will be negative 1, whose product will be negative 12. We're looking for these values, and as far as I can see, negative 4 and 3, right? It gives us negative 1 as sum and negative 12 as a product. So we can do that here. So clearly, it will be x minus 4 and x minus this, x plus this rather, and x plus this. So x plus 3. So your final factorized form after such a long time, we are finally there. Your factorized form is this. Okay. And now, if you look at the problem which we solved last time, we actually graphed this problem in our previous lecture. We have actually graphed this. And if you remember, we said that we'll have three, what was that, x-intercepts. So that means, because as we have 4 as the degree here, and we predict 4 solutions for x, but we had only 3 x-intercepts. That's why I said, if you remember last time, that we'll have one identical value, right? After we finish, if we go back to see the last video, you'll see this problem, okay? Anyway, so that's how you can factorize a bigger problem. But again, not every problem will be this long, because for many problems, after the first step up to this, you'll see that that's the last factorized form. You can't really factorize it anymore. But for some problems, you'll be able to, get this more factorized format as well. Okay, should we expect this type of poly to be fourth on the test when we analyze the polynomial function like we did in the 4.2? Okay, so that's a good question though, but I'm not sure how to tell you, because the main thing is when I'm setting up the question, I don't really check the most factorized form. Neither I want you to do that. So for the test, I think, okay, but we need that for all the x-intercept. Okay, so when I'm saying that you need to graph a problem, I'll definitely give you a factorized format, as I promised you last time. If you remember, yesterday I said this. I won't give you a problem like this, and suddenly I'll say, hey, you need to graph this. I won't do that. I'll give you a factorized format so that you can actually get the x-intercepts easily, or at least in this format, where you can factorize it easily. No problem, because as I said, I want you guys to work on the things which doesn't really make sense. Rather, I want you guys to focus on the concept. I want you guys to learn the concept. You don't need to go for the complicated problems. As long as you know the concept, you can always try complicated problems later on. But first of all, as this is a small semester, I want you guys to use this smaller period to learn to get the concept as much as possible. Okay. Anyway, so okay, all right. Thanks. Just got confused because it was on the homework and I got stuck. Help a lot. Okay, so did you get uh, uh, a problem like this where you needed to factorize up to this? Okay, and uh, what was the problem number? I'll give you full credit on it. No problem. Problem 5. Okay, I'll give everyone a full credit on this. Okay, as long as you have at least tried. If you haven't tried, I won't give you full credit. But as long as I can see that you have tried, or at least you have reached any of these steps, I'll give you full credit. Okay, no problem. So if I forget, just in case, send me a reminder tonight. I'll give you all a full credit. So that's 4.2 number 5, right? Okay, okay. I'll try to remember it. Anyway, so we'll stop it here. How much time will you get for test 2? Okay, I'll get there. I'll actually talk about the second test. I'll obviously talk about the third quiz, but let me first go for the asymptotes and discuss at least the core concept of that. I'll definitely talk about the tests and quiz